welcome to 4.2. This is our example problem. Let's dive right in. This table shows how many fat grams there are in some hamburgers sold by national chain restaurants. So we got saturated fat and we have total fat, and they're both in grams. We've got Burger King, Hardee's, Jack in the Box, McDonald's, and Wendy's. All right, so you can kind of see how they correlate with saturated fat and total fat. All right, so let's do part A. Find a linear equation to model the data. Saturated fat, total fat. So our saturated fat is going to be X, total fat is going to be Y. Okay, so what we can do is we can take all these numbers and put them into a list in our calculator. So as you see, what I have done is stat, enter, and you can see I have put all these numbers into L1 and L2. There's other stuff over here. They don't really matter. So we're going to do L1, L2. So it says we want to be able to write an equation for this. So if I hit stat, I want to go over to calc, and I want to do linear regression, and the equation that we have is a plus bx. So we're going to look at number 8. So I'm just going to type in 8. We want L1 and L2. We hit enter, enter, enter. And we end up with, right here, 2.8199. So we're just going to say this as 2.8 plus 2.3x. All right, this gives us this equation. Okay, so 2.8 plus 2.31x. So our equation would be, we're going to say this one's y and x, so we can say y equals 2.8 plus 2.3x. There's our linear equation. Tell the real-world meaning of the slope and intercept of your line. So first we know, what is the intercept of our line? The intercept is 2.8. So what does that mean? 2.8. 2.8 what? Well, we're talking about this first number is going to be total fat. All right? So it's going to be 2.8 grams of total fat. All right. Even if there are, or I could say when there are 0 grams of saturated fat. All right. So even if there aren't any grams of saturated fat, there's going to be some other grams of fat that are in the hamburger or whatever sandwich we're talking about. Okay. And what does this 2.3 mean? So this one was our y-intercept. And then our slope is going to be this 2.3. Well, that means the total fat in grams increases by how much? Well, increases by 2.3 grams for every 1 gram increase of saturated fat. Alright, so every time we increase our saturated fat 1 gram, the total grams are going to increase by 2.3 grams. Alright, so there's our real-world meaning. So there's part A, this is part B. Now let's do part C over here. Predict the total fat in a burger with 20 grams of saturated fat. Alright, so I'm going to use my equation y equals 2.8 plus 2.3x. Alright, and then I'm going to plug in 20 in for this x, because the x stands for saturated fat, so I know that's where I'm going to replace it with. Okay, so I'm going to have y equals 2.8, that should be an equal sign, plus 2.3, and it's going to be x. Alright, I'm sorry, it's not going to be x, because we actually have a number. It's going to be 20. It's going to be 20. There we go. Okay, and now all we have to do is just solve. Well, 2.3 times 20 is going to be 4.6 times 10, which is going to be 46. So we can say y equals 2.8 plus 46, and you would get y equals 48.8 grams. All right, so if we say 20 and 48.8 grams, well, let's see. If we go to our calculator here, what I did, and here is I plotted my equation. So if I look at my graph right here, I plotted all my points, and here's the line that I have. So if I want to be able to trace, let's just see where I'm at. 17 right there. 25. So if I go back, I want to find when x is about 20. Let's see if I was correct in my calculations. So I'm at 20.4, 20.0, and it's 49. So if we look at my estimate, 48.8, that's good. I rounded here a little bit on my equation note back here. I didn't round, I tried to use as many of the numbers as they gave me. So I think I was pretty good with my estimate there, okay? Another way to check this out is if I go to second table, if I want to go to my table, I say 20, 49.199. So there is a number right here. So I can just say plug in 20 into my equation and I get this number out. I say, great, that seems pretty close to what I had said. All right, then part D, predict the saturated fat in a burger with 50 grams of total fat. Well, what I'm going to do is 50 grams of total fat. That's going to be right in between 20 and 21, I'm guessing, right? So looking at that, I'm going to guess it's in between 20 and 21. Okay, so this time I'm going to plug in 50 in for Y, because that's the total fat, and we're going to say that equals 2.8 plus 2.3x. Okay, I need to solve for x. All right, so the first thing I'm going to do is I'm going to undo. Remember if we did that penny lab, we took away the pennies, the extra pennies first, and then we divided by the number of cups that we had. So we're going to subtract 2.8. I'm going to subtract 2.8. That subtracted show up. There we go. All right, so 50 minus 2 is 48. Minus 0.8 is going to be 42.2, and that's going to equal 2.3x. All right, so now I want to divide both of these by my 2.3, the number of cups that I have in that example. So we're going to divide by 2.3. We're going to divide this by 2.3. 42.2 divided by 2.3, let's just check that out by getting out of here. And we have 42.2, that's not right. It should be 47.2. Good thing I checked that out. 47.2. Okay, 47.2 divided by 2.3. So we have 47.2 divided by 2.3, and you get 20.52. So we end up with 20.52 grams equals x, so it's going to be 20.52 grams of saturated fat, which is really, really close to this one, right? It's just a little bit more because we're off by about 2 grams of total fat, and so we're 20 to 20.52, which gave us that extra little bit of saturated or total fat to make this all work. All right, so we predicted that based on our line of best fit, right? Looking at this blue line kind of matches all of our data pretty well. If I made my line a little bit different, that would make my predictions a little bit off as well. So using the line that the calculator gave us really helps out. All right, so there you go. Good luck with the assignment.